Welcome everyone. In this video, I will be covering section 11.2 about series. In the earlier video, you saw 11.1, which was all about sequences. Now from this section onwards, you're going to be seeing only about series. So that brings our attention what we mean by a series. If we add the terms of an infinite sequence, n varying from 1 through infinity, so we are going to add the terms. We get an expression of the form a sub 1 plus a sub 2 plus a sub 3 and so on, a sub n, which is called an infinite series. Or just a series, and is denoted for short by the symbol sigma n varying from 1 through infinity a sub n, or sigma a sub n. So for a sequence, we use a curly bracket. Sequence is only a list of members, list of items, list of numbers written inside a curly bracket. Here, we are adding the terms of the sequence, so we use the notation sigma. Next definition. Given a series sigma n varying from 1 through infinity a sub n, which is a1 plus a2 plus a3, etc., let Sn denote the nth partial sum. Meaning, you take a series and you add only the first n terms of the series. The S sub n stands for sigma I varying from 1 to n ai. So you give the values for I starting from 1 and go up to n. So it will be a sub 1, a sub 2, a sub 3, and so on up to a sub n. So the last value of I is n. I is the index. If the sequence of partial sum, make a note, Sn inside a curly bracket, n varying from 1 to infinity, is convergent, and if limit is n approaching infinity, Sn equal to S, exists as a real number, then the series sigma an is also convergent. So that we are going to be seeing several definitions of convergence of a series. This is one such definition through partial sum, convergence through partial sum. Then the series sigma an is also convergent, and we write a1 plus a2 plus a3, etc., an, and so on, the sum of the series as the limit of the partial sum, which is S. If you notice that this value and this value are the same, or limit is n approaching infinity an equal to S. So the limit of the partial sum, here is the sum of the series. The number S is called the sum of the series. If the sequence Sn, n varying from 1 through infinity, is divergent, which means that you cannot, if you're not able to find out an S like this, if the limit does not exist, or if it is infinity, then the series sigma an is also divergent. So the series is convergent if the limit of the partial sum exists and it's equal to S, and that the limit of the partial sum is the sum of the series. But if the partial sum does not, the limit of the partial sum does not exist or infinity, then the series is said to be divergent. Now let's see what we mean by a geometric series. You have seen this before in your pre-calculus class. We will redefine this. Sigma n varying from 1 through infinity, a r to the power n minus 1, which is equal to, when you plug in values successively for n equal to 1 will give you just a, n equal to 2 will give you ar, then ar square, so on, up to ar to the power n minus 1. This is the nth term. Then it goes on like this. Each term is obtained from the preceding term by multiplying by the common ratio. If you notice that AR, this second term, it's coming from the first term by multiplying by R. If you look at the third term, it is coming from the second term by multiplying by R. So the geometric series sigma n varying from 1 through infinity, AR to the power n minus 1, is A plus AR square, AR cube, and so on, up to AR to the power. It goes on and on. The nth term is AR to the power n minus 1, is convergent whenever the absolute value of the common ratio is less than 1, and its sum is given by sigma A R to the power n minus 1 equal to starting term divided by 1 minus the common ratio. Provided common ratio is, absolute value of the common ratio is less than 1, the geometric series sigma AR to the power n minus 1, n varying from 1 through infinity. In expanded form, it is A plus AR square, etc., is divergent whenever common ratio is more than or equal to 1. Whenever the common ratio absolute value is more than or equal to 1. So this is a very important series which will be used quite often um, for many sections to follow. So common ratio less than 1 means that the infinite geometric series converges. Then will converge. If the common ratio is more than or equal to 1, the infinite geometric series will diverge. What is a geometric series? The geometric series can be written in a shorter way like this using sigma notation. The expanded notation, this is the way you would write the geometric series. Find the sum of the geometric series. 5 minus 10 over 3 plus 20 over 9 minus 40 over 27, and so on. It says here it's a geometric series. Even if it doesn't say it's geometric series, and if it just said find a sum, you should be able to recognize a geometric series. The geometric series, the verification would be how it is geometric series. You know that it is of the form A plus AR square, etc. So if you divide any term by the previous term, you should get a common ratio. For example, AR square divided by AR square divided by AR equal to R. Same way AR cube divided by AR square would give you R. So any term divided by the previous term should be same throughout the series. So we'll just verify, even though such a check is not required in this problem, I'm just telling you this is one of the techniques that if you are not given it is a geometric series, how to know that it is geometric series, how would you verify? So A2 over A1 is negative 10 over 3 divided by 5. So that will be negative 10 over 3 times 1 over 5, which is negative 2 over 3. What is A3 over A2? Third term over the second term. That is 20 over 9 times 3 over 10 with the negative sign, which will be negative 2 over 3 again. So these two are the same values, which is the common ratio. So this tells us that what is given is a geometric series. Once you know that because the question is sum, then you use the formula A divided by 1 minus R provided common ratio is less than 1. So what is the common ratio that we found out? negative 2/3, and if you take the absolute value of it, it's surely less than 1. So common ratio is less than 1. So sum of this geometric series, I'm going to call it S. This is A divided by 1 minus the common ratio. A is a starting term, which is 5 in this case. The 1 minus common ratio minus 2/3. So it is 5 divided by 1 plus 2/3. That is 5 divided by 5 over 3. So which is equal to 3. If you 5 divided by 3 over 5, so which is equal to 3. So the sum of this geometric series is 3. Next example is a series sigma n varying from 1 through infinity 2 to the power 2n times 3 to the power 1 minus n convergent or divergent. As long as it's a geometric series, if you are able to recognize this as a geometric series, you need to bring the expression series into this form, n varying from 1 through infinity. If you bring the series to this form, then it is a geometric series. So it will look like it will be a geometric series. If you bring the expression series to this form. So first let's bring it to that form and then identify the common ratio and then see whether it is convergent or divergent. So step 1 is to recognize this as a geometric series. So consider this n varying from 1 through the infinity 2 to the power 2n times 3 to the power 1 minus n. So we will adjust this 1 through infinity. We will write this as 2 squared to the power n. Then 3 to the power 1 minus n can be written as 3 to the n minus 1. If you bring this 1 minus n on the numerator to the denominator, the signs will get switched. So 1 minus n on the exponent on the numerator will become positive n minus 1 in the denominator. So now we have written this as n varying from 1 through infinity, 4 to the power n over 3 to the power n minus 1. So now we want to recognize this as a geometric series. So we want to bring the expression to this particular form. So it is considered this given series sigma 2 squared to the power n divided by 3 to the power n minus 1, where sigma n varying from 1 through infinity stays as is. The sigma 1 through infinity, we have 4 to the power n here, 4 to the power n, which can be written as 4 to the power n minus 1 times 4. What is 4 to the n minus 1 times 4? So it is 4 to the n minus 1 plus 1. If you add the exponents, that will become 4 to the n. So divided by 3 to the power n minus 1. So this 4 is independent of n. So it can come out of the sigma sign, sigma n varying from 1 through infinity. So this can be written as 4 to the power n minus 1 over 3 to the power n minus 1. So it is 4 by 3 to the power n minus 1. Even if you keep this 4 inside, it's not going to hurt. So it is of the form sigma a r to the n minus 1. So what is a? A equal to 4 and r equal to 4 by 3. What is the absolute value of the common ratio? Which is more than 1. Therefore, the geometric series diverges. So this condition of common ratio more than 1 less than 1 work only for the geometric series. So you have to recognize the series as a geometric series. Sometimes it won't be obvious. You have to do some kind of manipulation that we have done in this problem to make it look like a geometric series, and then look for the common ratio. If the common ratio is less than 1, you can actually find out the sum of the series, like the previous example. Otherwise, you have to say the series is divergent.